Our next speaker, huge privilege for me to be introducing Pamela Jasper, a global financial services tech leader, 30 years experience in front office capital market trading, quantitative risk management systems for investment banks, exchanges in NY, Tokyo, London, Frankfurt. She developed a proprietary credit derivative trading system for Deutsche Bank, a quantitative market risk VAR system for Nomura. She's CEO of Jasper Consulting, Inc., consultancy firm for advisory and audit services for AI ethics governance. She's got experience as a software developer, auditor, model risk program manager, and she created an AI ethics governance framework called FAIR, Framework for AI Risk. Pamela, it is wonderful to be hosting you here. Are you there?
Yes, I am here. Can you hear me?
Loud and clear.
Awesome. Thank you so much.
The stage is yours.
Thank you for having me. So again, thank you everyone for joining in and participating this afternoon. And thank you to Richard and everyone at the Milton Keynes organization for having me. My title today, I believe it was Baking in AI Ethics at Every Stage. Over time, I thought about that and realized that while I'm not really going to focus on the title of my discussion, I'm going to include certain principles that we'll discuss: model risk management, AI ethics, and data disclosure. And I do have a presentation, so just bear with me as I try to share my screen. Okay, can you see the presentation?
We've got it on layout. There we go, full screen, brilliant, thank you.
Okay, great. So today I'll be talking about briefly, just context, why data disclosure, why this is important and relevant for us today in this day and age and at this time. A little bit about my framework and how it relates to data disclosure and why, again, data disclosure is important, but in a bit of context. And then I want to highlight the work actually of a colleague of mine, another researcher, John Hill, and some thoughts that he has also leveraging one of the core components of my framework, which is SR 11.7 or model risk management, and then we'll summarize from there. So why AI data disclosure? Well, I looked up some random definitions of data disclosure and found a good enough definition that I think for today we can use, which is the act of making new information or secret information known. So I think that when we think about data disclosure, this is relevant in terms of artificial intelligence and in machine learning from two primary actors. One would be consumers, people, individual, and the other would be the actual companies or technical companies that are building and manufacturing the AI products. So for consumers, when we think about data disclosure, elements that come to mind that's really important are around social media privacy, as an example. It's very important for us to maintain knowledge and awareness of when our private and secret information is being shared, but also to participate in and consent when for allowing that data and information to be shared with various parties, especially when using an artificial intelligence or intelligent system. Companies, on the other hand, they're looking, when we talk about disclosing information, the disclosure of that information for a company that's building the AI obviously needs to be balanced internally with their sense of intellectual property, their IP. And one of the cultural demands, or one of the cultural motivators for this, has been algorithmic bias and this rise in consciousness and awareness and discussion, I think, as someone recently mentioned in one of the chats, about AI ethics. So these types of discussions have put a lot of pressure on companies to disclose their data and to disclose their processes and information around AI and the decisions that AI is making that impacts these types of outcomes. Excuse me, I'm just going to go back up. So FAIR is a framework for AI risks that I created based on the many years of experience that I've had in not only designing, not only as a software developer and designing quantitative, algorithmic risk-based systems within the banking industry, but also in working on an application of a bank regulation called model risk management. Model risk management is a bank reg that covers the usage and development and validation and testing of all models within the banking infrastructure. And that includes modern day machine learning and AI models. So this slide is just to talk a little bit about the history of model risk management. And I want to be clear, again, right now, I think, there's a belief that there are no regulations around AI. There may not be very tangible or on the ground specific regulations that specify actions around AI, but there are regulations around model risk management. And for US banks, for many of the Canadian banks and many European financial institutions, they are definitely regulated under these regulations. So in the year 2000, the OCC in the United States, Bulletin 2000-116 from the US Office of the Comptroller of the Currency, focused on model validation, was the first formal supervisory guidance on model risk for financial firms. Basel had capital rules. The Committee of European Banking Supervisors in 2006 had a regulation. The European Union solvency rules for insurers, or European Parliament in 2009, focused on model risk. In the United States, again, the Federal Housing Finance Agency in 2013 focused on model risk. The SEC covers model risk. And also Canada, their Superintendent of Financial Institutions in 2017 created regulations around model risk. The most widely known model risk guidance is SR 11-7, the supervisory letter that was created, the seventh one that was created in the year 2011. And that was done by the Federal Reserve Board, and that governs, based on materiality in terms of capital assets under management, most US banks. Why was this model risk regulation required? Because as someone, I think Nikita once mentioned about AI in general, AI is a type of system, and it's not only a type of technology, but it's also a type of model. So model is the meta definition, whereas AI and machine learning is a specific type of model. And model errors have occurred throughout the history of humanity, as long as we have been using and leveraging models. Another example would be long-term capital management in 1998, obviously the 2008 financial crisis, which was driven in large part by the Gaussian cupulas and the pricing of the structured products. And what I argue right now is that AI and machine learning bias is a major driver of why model risk management needs to be looked upon. Awareness, we need to build awareness on model risk management and have it become a baseline sense of framework or backbone for all of our machine learning practices. And I'll tell you why in a minute. So when we look at model risk management, and these are the high level components of model risk management. And those are the components that I've included in the FAIR framework. Model risk, the actual definition, what is a model risk? What is an AI risk? What does it mean to have a risk in your machine learning? Defining a model grade. I think Nikita, as an example, discussed, disclosing information similar to nutritional labels. So we want to actually also apply a specific grade, whether it be numeric, whether it be mnemonic, A through F, 1 through 5, A being less risky, F being most risky, but a very specific definition of this model's risk. And again, banks are doing this right now. So this is nothing new, and this has been in existence for over 10 years. Model risk reporting, model risk governance and charter. We need a model risk board, a group of people who evaluate decisions like we just talked about. What type of cultural norms will drive our value systems? Will it be Ubuntu or will it be Buddhism? That depends on the use case. These types of decisions, how are we identifying the risks for our organization, et cetera, are defined here. An AI ethics risk register, model inventory, model IDs, model tiers, an AI ethics risk analysis, transparency and disclosure, AI events, model development process, the model validation exercise itself, model limitations and model usage, periodic model reviews. This has been regulated by the federal government for the last 10 or so years. Model findings, how do we identify and disclose model findings, roles and responsibilities, data governance, bias analysis, and AI audits. So these are all, these are the high level components of the framework. The benefits of it are of leveraging SR 11.7 is that it's based on regulations. So, we're not saying that we're not regulated. Artificial intelligence in banks today, let me be clear, are regulated. It's not like that those models are not regulated. They fall under this purview, and most of all of these practices govern those models. There's a 10-year proven record. We know what we're doing. We've been doing this for a while. There's an existing ecosystem. And again, regardless of the use case, whether you're talking about facial recognition software, criminal justice AI, machine learning, human resource, hiring, employment practices, machine learning, modules, whichever your use cases are, model risk management is agnostic, and thus it is transferable to any industry. Hence, I call it model hygiene. I'm just going to move through this quickly. So this was another depiction of the framework that I presented at the conference NeurIPS in 2020. I just want to focus a little bit here, if I can move this thingy, whatever, on the traditional machine learning development lifecycle that everyone's familiar with. Design, there's some pre-activities, there's design, there's managing the data where you define your data, acquire your data, clean your data, splice your data, define your algorithm, train your algorithm, test your algorithm, vet and approve your algorithm, and then deploy and monitor it. For each of these life cycle phases, or baking this into each stage, AI ethics and data disclosure occurs. So during the pre-design elements, where you're defining your risk register, your policies and procedures, this information needs to be documented, and at any time, regulators or supervisors can ask for information on this. So because it's well documented, it's available or disclosed both internally within the company and externally. Design, again, if you're using an agile or waterfall methodology for your machine learning development lifecycle, You're either going to have some form of BRD, some form of user story, some form of backlog, some form of specifications. And at each specifications, you want to identify what are your data attributes that relate to AI ethics, meaning if you are, how are you identifying and addressing bias? How are you identifying and addressing trust, safety, security, privacy, etc.? All of the typical and traditional AI ethics metrics that are included. You want to have a plan for that and how you're addressing that up front. The data, are you using data sheets? Are you using data specifications? So again, baking those decisions in and documenting them for data, for disclosure at this phase. The model, typically when we talk about disclosure at the model level, we're talking about XAI, explainable AI, interpretable AI, and what I'm going to present, hopefully if I have time in today's discussion, smart models. Finally, during the approval process, again, model grades, model cards, model validation report, all of this information needs to be available to both regulators, external consumers, and your customers. And finally, during the deployment, once your API, your AI, machine learning, is in the real world, so to speak, in the production environment, as people are saying, well, the problem of bias, as an example, is in the data. So if we clean the data and cure the data of bias, which I admit may never become 100%, but we need to focus.
Let's give Pamela a moment to return to our screens.
I don't know.
Are you there, Pamela? Perfect.
Can you hear me?
Welcome back. We lost you for about 10 seconds. Yeah, we just lost you for a few seconds.
I kicked the thingy.
No problem.
So these are the phases of the development life cycle, and at each phase, it's important to think about, consider, bake in your design considerations around AI ethics and disclosure. During the deployment, when the model is in the production environment, as someone mentioned, humans are biased. And the problem is, if you do clean the data of bias, once it goes into the live environment and continuously takes in normal inputs and daily day-to-day inputs, that can retrain and allow the model to relearn existing human biases. So this isn't a standalone effort. It must be done in concert with the community. And so when I talk about the community, another aspect that my framework looks at is how can we have and develop feedback loops with the community. So here, one way of doing that is leveraging feedback loops directly from consumers. So AAID is a database that Partnership on AI created. But there are several other organizations that have created similar databases that track user complaints of actual AI harms. It's very difficult for us to address differences or problems in your AI if no one ever gives you feedback that there's a problem with your AI until a very severe event occurs. So here's a draft of a framework where the developer, during the machine learning development lifecycle, sends a product to the AI consumer. She has an AIID app. On her app, she can log an AIID event. It's cataloged, it's categorized. It sends that information back to the developer, as well as back to the policy regulator. So now the developer with that information over time can understand better, if I create an unsupervised model for whatever my use case is, how many times in the past week or month or year has this type of use case with this type of model or algorithm caused a problem? It's important for me to know that and get that feedback, not only on my particular product, but also on commercial products in general. And an example of, within my framework, within my framework and within SR 11.7 of using a model-based approach, a risk-based approach, is where we work with model tiers. I don't think I'm going to have enough time to go through this, so I'm just going to skip through model tiers and model grade. I want to go directly to John's talk, and if we have time, I can go back. So SMART models is a concept that Professor John Hill created. He's a professor at NYU, and the idea behind SMART models is that models need to know who they are. This may be accomplished by embedding a unique identity token and an active intelligent agent within a model's source code. So all of this text and information that I'm sharing with you right now is not my work, but is John's work, although I'm annotating it in some cases. Why would we need a model to know itself? You know, bank examiners often ask questions like, can you provide a complete list of the models used by each of the above entities over the past year, as well as all upstream and downstream model and data dependencies? Are there any models that were executed on any of your firm's computers that do not appear in your inventory? So how do you know if all of your models are live or not? Were there any instances of a retired model still being executed during the last year? Again, many of the larger banks have upwards of 2,000 models in their inventory. To keep track of where each and every one is requires a manual attestation and manual evaluation. But with SMART models, we have a way of models knowing who they are. And we do that by two components here. One is called an identity token, an ID. For those of us in data, it's a unique model ID. So right now in our model inventory databases, typically we track the model IDs, the model version, model usage, et cetera, but it's in a database, an inventory database that's separate from the actual model. What we're saying here is that the model code, the actual source code for, you know, in this case, the Black-Scholes pricer model, which is an options pricing model based on Black-Scholes randomness, has in the source code model ID, model version, model usage. In addition to that, outside of the model, the firms will have transponder agents where the model itself can broadcast to these agents, like a transponder would, information about the model. So I like the transponder analogy because I'm a pilot. I fly airplanes and I fly helicopters as a hobby. And every aircraft, we use transponders to broadcast our location and, most importantly, who we are, where we are, and who we are and where we are. Similar to how we do that in aviation, models need to know who they are and transfer that information or broadcast that information. So they would broadcast their model IDs, their model name, their version number, the timestamp, day, hour of every time that model is executed in production. Conceptually, this is the conceptual image. And then I think at 237, I kind of want to close up with, this is not just vaporware. SAS is actually implementing SMART models right now. So some of the, the Big 10 tech companies are leveraging model risk management, are leveraging SMART models, and are beginning to use this type of technology. And here's another image of how FAIR would look like now with the blue image around SMART models. So now our consumer, she's not only using an AI ID app. This is my drawing of a cell phone. Okay, I'm not an artist, but in her other hand is the blue app, which is the SMART model. That's the actual AI device. That device is broadcasting back to the development company. Hi, this is who I am, model ID number, blah, blah, blah. This is where I'm using this. I'm being used in every existing instance. as well as to policy regulators, so that we can start to build a global ecosystem map, dynamically tracking each model instance. Now, I know you were talking about petabytes, terabytes, and metapetabytes of data in this case of collection, but this is where SaaS and this is where some of the most innovative companies are thinking about, and these are the conversations that I'm having with my clients. My name is Pam Jasper. I offer advisory services for AI development, financial and other firms around AI ethics and governance. I can help companies to ensure that your executive team is fully informed on the issues around approaching and implementing AI ethics. I support companies with AI ethics policies and procedures. All of this is leveraging my custom framework for AI risks, and provide program management and on-the-ground AI ethics governance and AI ethics audits. I can be contacted at jasperconsulting.ai or pam@jasperconsulting.ai. I don't know if I went over time, Richard.
Thank you. Thanks, Pamela. I think we are spot on. And I think it's a wonderful talk showing the framework that you have created basically based on the risks of AI and the model risk management that needs to be used alongside, and how it can be agnostic and extended to all the industries basically. And the feedback loops will be so important, and data disclosure, how it is important for consumers and companies themselves is important as well. But having a database of all these, the documentation, the governance boards, rating of the AI models, how important it is going to get as we step in more and more into the AI world, I think is the key to building a smart model and a whole ecosystem which is ethical and responsible. I think I thank you once again, and I let you answer the questions onto the chat because we are running out of time at the moment. Thank you again, and handing over to you, Richard.
Thank you, Jazel. And thank you so much, Pamela. It was a wonderful talk. You covered so much in that time. We'll of course be sharing these replays for people to tune back into what you said. And I've shared your URL for your brilliant website on the chat. And you hit us perfectly on time, brought us back 4 minutes as well. So we're even more thankful to you, Pamela. Thank you so very much.
Great. Sure. Are there any questions now, or should we defer those to later?
There's some questions in the chat. So if there's any chance you could physically type into the chat to have a look at some of those, though I did see 2 or 3 coming through, if that's okay with you, Pamela.
Okay, sure.
Thank you so much.